Okay, now, here we have, in exercise 11 through 14, find f of g of 3. And for consistency of notation, could we write this another way?
F of G.
We could write this as f of g of 3, right? Or g of f of 3. So, or negative 2, g of f of negative 2. So these are alternative notations. Thank you. So let's go ahead and work these out. What do we do first? Do you have an idea?
Times them by each other.
Okay, who said times by each other? Okay, that's an operation of functions. Okay, this is a composition. This little circle means a composition. But yeah, like if I just looked at this, the first thing I would think of would probably be what she said. Okay, so I'm glad she brought it out.
Do you substitute those numbers for the...
Yeah, so this goes back to that function machine we were looking at yesterday. Remember that? So the first thing we're going to do is take this 3 and put it through this g. So g of 3 is equal to 3 plus 1, right? So g of 3 is equal to 4. So now what do we do with this 4? We take this 4 and we go right in for this thing right here, for this x. So f of 4 is going to be equal to 2 times 4 minus 3, which is 5, okay? And now we've taken this number 3, we've run it through the first function machine, which was this, came out with 4, and then we take this 4 and run it through this what? This other function machine. And then we end up with 5. So we can make a concluding statement, which is going to be in the wording of the original, right? So f of g of 3 is equal to 5. My pen is a little glitchy today. Okay, questions on that one? You good, Carmen? You good on that? Okay, everybody's good. Okay. Now what's going to be g of f of negative 2? What's that going to be? I want to write this one in red. So what do we do with this negative 2 first?
I'll plug that into the F.
So let's do that, okay? So Will suggests we take this, and sometimes I think on these, it might help just kind of circle there to kind of show, so you look at the one that's adjacent. So we want to have first f of negative 2, and we plug that in, we get 2 times negative 2 minus 3. So what is that going to be? Negative 7? I think so. So now we take this negative 7 and run it through where? The other one. So we're going to have g of negative 7 is equal to negative 7 plus 1, which equals negative 6. So now we can write g of f of negative 2 is equal to negative 6. Okay. All right. You good? You good on this? Everybody good on this? Any questions on this one? What I want you to do is go ahead and work out 12 through 14, and I can help you out with those as we go to that point, okay? Good job. Somebody I hope Kenzie's gonna be watching some videos. I don't know what is she actually pretty ill?
Yeah, she got tested today.
She just got tested,
Yeah, her results aren't.
so not results, but how does she feel? Is she feeling okay? You don't
She's
know?
okay, I guess.
She's probably okay.
Yeah.
Yeah, I think I got it last year around the same time Caleb, I think, got it, and probably others too, but she's the one I remember most being run down around the same time I was. So Kayla, last year when you had this thing, did you have a fever too during the?
Sometimes.
Sometimes, yeah. Well, the thing has different symptoms for different people. For certain young people, you have hardly any symptoms. Hard to tell. So, Okay, any questions on these other ones? Want me to look at one of them? You're just too busy doing your good work. Questions on anything? Okay, are you okay on these? You okay on these? Let me know if you need to work one of them out here. Do you remember yesterday when we were interrupted by the canine search? And I had about 3 minutes of video after the canine search. Well, I spliced those two pieces of video together and made one out of them. Worked okay, wasn't too bad. Emily, okay on these? You finished through 14?
I'm just looking at it again.
Just kind of looking? That's fine. Sometimes you just have to look at these things and sort of wrap your mind around it and take some time looking at it. That's good if you're doing that. Which one? Number 12? Okay. Do you want 12 to be worked out, or do you have a more specific question than that?
More specific question.
Okay, what is your,
Remember, we probably get this.
okay. So you plug in 3. Plug in 3 into this one first, right? And you went through and you ended up getting 3, right? And then you plug in the 3 here and you get that. Yeah, that was right. And then you plug in the -2 into the F, right? Yes, you did. Yeah, I think 2 parentheses. That's right. Yep. So, yep. What's that? You got 8 and 3 for me. Yeah, that should be, that's right. I remember that from 5th period. That's right. Yeah. Yeah. Oh, yeah. Yeah, 0 over 1, 0.
So 0 which is here.
Right. You got 0 numerator divided by some, that's 0. Any other, answer a couple questions, any other questions on these? I think for 14, one of the answers is 0, right? Did you see that? Are you gonna be ready to go on to number 15 here?
Can we work on that one?
Which one?
Number 12.
12, okay, 12. Okay, first thing we're gonna do is, I'm gonna take f of g of 3. So we're gonna take g of 3. So we're gonna take this right here. So we're gonna get 2 times 3 minus 3 equals 3, right? And then we're gonna take this 3 and run this 3 through in place of that x. So f of 3 is equal to 3 squared minus 1. So we make our concluding statement, f of g of 3 is equal to 8. So that's going to be f of g of 3. Okay, did you get that one? And then the other one, g of f of negative 2, f of negative 2 is equal to, we just plug in negative 2 here, so negative 2 squared minus 1 equals 3. So now g of 3, because we're plugging in that 3 into this thing right here now. So we have 2 times 3 minus 3. So we can conclude g of f of negative 2 is equal to 3. Is that what you got for that one? Okay.
That's what I got.
Okay. Well, that's the same. All right. See, in one of these, I think you get 8 for f of g of 3, right?
Yeah.
And for the other one, you get 3, right?
That's what I got.
G of f of negative 2 equals 3. This one here, f of g of 3 is going to be 0, right? And g of f of negative 2, so you get negative 2, should get 5, right? So g of f of negative 2 is 5. Okay, so I just gave you answers there. Part of it is because I remember a little bit from last period, okay? So you ready to go on to 15?
No,
You're not?
I'm still working out.
Okay, well, we're going to need to go on to 15 here. A second. Let me give you another minute, then we'll go on to 15. Okay, so looks like most of you are done or are pretty close to it. So I'm going to go ahead to, you're finished with it too, Carl, aren't you? Okay, we're going to go on 15 here. And right here, what we're doing, instead of running through a number through the function machine, we're actually creating a new function. And here, it says state the domain of each, right? So what kinds of functions are both f of x and g of x? They're linear functions, right? And linear functions come from the larger family of functions we call quadratic's kind of related. That's like the next power up. Polynomial functions, right? And what is the domain of all polynomial functions?
All real numbers.
All real numbers. So when it says state the domain of each, we already know the domain of each is going to be equal to what? All real numbers. Because there's no way we can get an exclusion from polynomial functions that are in the numerator anyway. Okay? So now let's go ahead and work these out. We want f of g of x, and f of g of x is the same as like fog of x, right? And so, how do we get f of g of x? What's next to the x? G, right? So what we're doing is we're taking g and plugging it in for this x right here. So we'll have f of, well, f of g of x, but I'm going to put f of x minus 1. And so what we're going to do is we're going to replace this x with x minus 1, which is going to give us 3 times x minus 1. Now, once we do that, pardon me? Yeah, Kaylee just said it. She just said what I was about to say. Thank you. She's very observant. Good job. Yeah, what happens when you do this, it's easy to forget that plus 2, because you're just replacing that x. And now, f of x minus 1 is equal to 3x minus 3 plus 2.
You can combine
It's combining like terms, so what are we going to have left?
3x minus 1.
So we can write our concluding statement here, f of g of x is equal to 3x minus 1. And so that's going to be that one, okay? And our domain, of course, is all real numbers. And now for the purposes of color coding, how do we find g of f of x?
Put it as x on g of x.
Yeah, so we're going to take this f1 here and put it in place of this. I'm going to see if I can get the phone to work, because I haven't been able to get this phone to work since I've had it. Hello? 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 Okay, so now we got to take this and plug it in here. So we say g of f.
Pardon the interruption. Could you send Angel tomorrow to the office, please?
Okay, he's coming.
Thank you.
So g of 3x plus 2 is equal to
3x plus 2 minus 1. Which will be 3x plus 1.
Okay, similar, and they have the same slope but different y-intercept, right? So that's really what there is to it. Questions on this one? Now on this next one, 16, are we going to run into something a little bit different on the domain here?
Is it excluding something?
Yeah, I ask you, are something excluded here for this problem, 16?
Is it positive 1?
So 1 would be excluded, right? So that's an exclusion for one of them. So just keep in mind, when you have variables in the denominator, you will most likely have exclusions. Except if you have x squared plus something.
You should help us with this one.
Yeah, you really should.
You think so? Okay.
Yeah, we need help with it. I want to try it first.
Okay, let me give you another minute to get started on it, and then I'll do this one, okay? Hope you're okay. Are you okay, Angel?
I don't know.
You don't know?
Probably.
Angel, you can take your work with you, and you can watch a video on this tonight, whatever we finish up with. All right. You ready? Okay, we're going to look at this now, right? So now we have f of g of x. So we're going to take this g of x and plug it where? In the place of this x right here. So we're going to have, oh, I'm just going to write it in the notation. So f of g of x is going to be equal to, in the place of x there. So we're just going to go ahead and put this in the place of x. So I'll put 1 over x minus 1 in squared. Okay, you see that that's in the place of this x here, and then minus 1 out here. So now we have f of g of x is equal to, what's 1 squared? 1. And then we can just take our denominator and we can just rewrite this as the, and then minus 1. And so that's going to be our answer. And what is our domain for this going to be? And Hannah was mentioning what it was earlier. What is that going to be, our domain for this?
Negative infinity to 1, union 1 to infinity.
Okay. All right. Any questions on this one?
Wait, I got it. It's actually the other part, right?
Yeah, then the other part too. Okay. And you want me to do that one too?
Yes.
Okay. It's the same sort of thing, but we're going to take this one here and put it in place of this x right here. So I'm going to write this as g of f of x
Now,
is equal to 1 over, I have x squared minus 1 minus 1. So everything is the same except this is what's replacing the x, right? So now, if we simplify this, what are we going to get?
1 divided by x squared minus 2.
1 divided by x squared minus 2. Okay, who was my worker on that one? Okay, oh, yeah, that's going to be it. Now, what is our domain of this function here?
There has to be minus 2 at the end, though, right?
Yeah, and what it is, you took this replacing the x, so simplifying, you're going to be left with x squared.
Also, isn't there a minus 1 here?
Well, yeah, the minus 1, yeah, the minus 1 came here, see? So here's the minus,
There's another minus 1 on the other one. There's 2 minus 1s.
yeah, there was a minus 1 here, right?
She's talking about after you substitute for the x, you still have a minus 1 on the
Yeah,
original one.
right
But
here.
you also have another minus 1 on the one you have to substitute with. Is that what you're saying?
Yeah, but then it combines to make minus 2.
But there are 2 minus 1. There's,
So we replaced this x right here with x squared minus 1. You see that? This x squared minus 1 takes the place of this x, right? And so what we're left with is x squared minus 2 in the denominator, right? Okay, what is our domain of this? What is our domain of this thing going to be? Okay, we know that x squared minus 2 cannot equal what? 0. So x squared cannot equal 2. And so what can x not equal? X cannot equal what? Take the square root of both sides, what do we get? square root of plus or minus square root of 2. So x cannot be plus or minus square root of 2, because what would happen if this is plus or minus square root of 2? 0, right? So what is our domain for this guy right here?
Negative
Negative infinity to
plus
negative square root of 2, union negative square root of 2 to 2, or to square root of 2, and then union square root of 2 to infinity. And I'll have you know that I know this is the right answer for one thing. We did it in 5th period, and we checked in the book.
I don't understand
You don't? But see, what part do you not understand? Do you understand this part
I
here?
understand the first part, where we got the 1 over x minus 1 squared minus 1. But then when we plug that into the
Here?
other one,
Or the red one or the green one?
no. When we plug the red one into the green part,
Okay, so this one into here?
yeah.
So this red one here you're talking about?
Well, I understand that part, I just don't understand when we plug it into the other one.
So you don't understand this one into here?
They're two separate equations.
It's two, you don't plug in the other one. So you don't plug in the green answer, or you don't plug in the red answer to the green.
Yeah. Yeah, so they're separate problems is what you're saying, right?
Yeah.
Okay. Okay. Let's go on here. So do we have a domain restriction on f of g of x?
Plus or minus 1.
What's our exclusion you see right here? You're right here. That's your exclusion. Okay. So x plus 1 is what? Greater than or equal to 0. So x is going to be greater than or equal to negative 1. Okay? That's going to be for this thing right here. So is this domain restriction going to carry on no matter what we do? Yeah, because this is already tainted with this restriction. So now how do we work it out from here? F of g of x. So f of g of x is equal to, what do we do with this thing here?
Plug it in.
Plug it in for this guy here, right? So I'm going to bring this square root of x plus 1, and what do we do with that? Square it,
So wouldn't that just cancel out?
and then subtract 2. Yeah, let's go ahead here. So f of g of x, and you're saying that these will cancel out each other? Yeah, so it's going to be
It'll be
x plus 1 minus 2. So it's going to be f of g of x is equal to x minus 1. Now, is there anything in this that tells you there's a domain restriction? No, there isn't. But we know there is one because of this thing right here. So we still inherit our original domain restriction. So our domain for this guy is going to be what? Negative infinity to greater than or equal to negative 1, less than infinity. Okay? And then what is the other one going to be? It's going to be this one into here, right? So g of f of x is going to be equal to square root of, and sometimes when I do this, I like leaving a big parenthesis space in the place of x and leaving everything else the same. So I bring the plus 1, I just leave this big parenthesis space, and I'm going to put x squared minus 2. Does that look right? So for this one, we're going to get, is that going to be x squared minus 1?
Yeah.
Now what do you know about this thing in here? It has to be what? What do you have to be inside the radical? What numbers can it be?
Anything greater than 0.
Actually, greater than or equal to 0. Okay. So we have this x squared is greater than or equal to 1. And so what is this going to translate into? It's going to translate into, how's that going to translate?
Thanks, sir.
How's that going to, what's the domain going to be of this thing? Okay, what you're going to do is when you take the square root of both sides, you're going to get x is greater than or equal to 1, but also x is less than or equal to negative 1. So this will be your domain here, and you can write that in interval notation as, how do you do that? Domain, negative infinity, 1, and then union, that's supposed to be negative 1, right? And then that's bracket 2, 1, comma, infinity. What I want you to do is take your calculator and see if that's the case here for this one. Tell me when you graph that. You see, I'll do it right here. X squared minus 1. Yeah. Square root of x squared minus 1. Do we get the same thing there? That's it, isn't it?
Yeah.
Okay, so that looks good. Okay.
Yeah,
All right, let's see, what time are we
5
going?
minutes.
5 minutes, okay. What I want to do is, I'll just see what this one looks like. Okay, I think we'll be good on this one. I think we'll just wind it down then. Thank you.